Hi class, my name is Moshiri Nyaga from the School of Computing and Informatics. Today we want to focus on a topic in anatomy of the computer and different parts of the computer and how each part of the computer is used. We start with the definition, or the objective of this class is to check the what is a computer, different parts of the computer, and how we can use a computer. In human affairs, we have reached a point where problems that we must solve are no longer solvable without the aid of computer. So my fear is not lack of computers, but the lack of them. That means in the near future, we might depend more on computers, and we cannot live without these computers. So what is a computer? Computer can be defined as an electronic device that can follow instruction to accept input, process input, and then produce information. Take note that the input is defined as data. What is data? Data is low facts and figures that are not in a structured way. So information, or a computer, is used to process that information to information. So when you're asked about how do you define information, information can be organized data and given proper information. So a computer is just an electronic machine that is used to input data, process data, and give out information. So what is a computer made of? We have two major areas in a computer, or two major components of a computer. We have the hardware and the software. We cannot separate both the hardware and the software. So a software can be defined as the untouchable, or the things that instructions that you cannot see in a computer. What about a hardware? A hardware, this is the tangible bit of the computer. So what is a hardware? Hardware can be things like a monitor, a central processing unit, a RAM, a processor, a joystick for those gamers, and then we have the speakers, the mouse, the floppy drive, the CD-ROM, the hard drive, and the keyboard. The hardware bit is listed, or can be divided into four major elements. The first part is the CPU, into brackets, the processor. On our definition, we discussed about processing. And so when we discuss about a processor, that's where the data is processed to give out information. And that in the processor, we still have a bit of another section that is called the main memory. That's where the computer stores information before it is processed in the CPU. The other tangible bit, we have the input devices. The input devices can be said to be the devices that are used in a computer to input data. An example, we have the keyboard, we have the mouses, we have the microphones, we have the joysticks, etc. So any tangible element or physical device that is used to input data, it is an input device. The other bit of a hardware device is called the output device. It's called the output device. So the output device is devices or tangible devices that are used to give out information or present information. Example include the monitors, right? We have speakers, we have so many things, the tangible screens, etc. The other tangible device are the storage devices. The storage devices differ. We have the primary storage and the secondary storage. We are going to discuss as we move on about the storage devices. In a nutshell, in the storage devices, we have two major devices. We have the ROM, or the random access memory, and the random read-only memory. The computer, it is housed in a cabinet, or the housing of a computer, or it's housed in a box commonly called as the system unit. The system unit, you can see this is the system unit. It houses the RAMs, it houses the drives, it houses the power supply and everything. The green thing, you can see it's commonly called the motherboard. The motherboard assembles all the circuits in the machine, and we're able to communicate with one another. As earlier stated, we talked about the hardware. We have the CPU, the input, the output, and the memory. All those are housed in the system unit. So, how does a system unit work? This is just the general overview of how information flows in a computer. The first part is the data, and we define data as raw facts and figures. And in IT, we also include symbols and unstructured data. So the data moves from this form and then to the input unit. The example of the input units include the keyboard, the mouse, etc. So after data moves from the input devices, it goes straight to the central processing unit. The central processing unit has three major elements. The first element that we can see here, it's the control unit. The control unit focuses on coordination of all activities in a computer, right? And the abbreviation is called the CU. Still on the central processing unit, we have the arithmetic logic unit. The arithmetic logic unit, the work of the arithmetic logic unit is used to process all the mathematical functions in a computer. That include the subtraction, the addition, the matrices. All the simulation are done in arithmetic logic unit. The other very important element in a computer is the memory. As earlier stated, we have two major types of memories. We have the random access memory and the read-only memory. The read-only memory is used to hold an instruction, or when you discuss about or when you talk about an instruction, we are talking about a software or a program, right? So any information before it is executed, it is held, it's given, or it's at the random access memory. So the bigger the random access memory, the faster the computer will be. The next memory is the, let me go back to the random access memory. The random access memory is used to hold an instruction, and it stores this information temporarily. Take note, this memory is volatile. When you talk about a volatile memory, it means that it requires electricity to work. Once the power goes off, the instructions that are at the random access memory also disappear, so they are volatile. The other memory is the random read-only memory. In the read-only memory, instructions or softwares or programs, in other terms, they are stored there permanently. An example of that, they are those software or instructions that are installed in a computer. They are all stored in read-only memory. The other bit, once the processing or once an instruction goes to the arithmetic logic unit or a RU, and it is processed, the next bit, it goes to the control unit, and the control unit determines when the information is supposed to be released. So from the control unit, the information goes to the output unit. So what are these output units? We're talking about monitors, speakers. An example, let's give an example. You're using a speaker to talk, or no, a microphone to talk. So a microphone, you're going to talk via the microphone, and the information will be processed, and then the output unit will be the speakers. Right. In an example, a computer-based mobile phone, you can use the keyboard to input data. Then we have the CPU inside the computer, and the screen of your mobile phone. That's the output unit. So how is this information organized? So we've talked about the input devices. You can see on the figure that a physical input device, and then inside here, this is a simulation of a motherboard. So once the input enters information in the motherboard, it goes straight to the CPU. You can see these are CPU. A CPU then processes the information from the RAM. These are RAM. These are hard drive. A hard drive can be defined as a read-only memory because it stores information permanently. So after this, the read-only memory processes the information, and this is a simulation of a CPU. The meaning of a CPU is just a central processing unit. This is how it looks. So that's the simulation of how the hardware organization is meant in a computer. So in most cases, green is the default color, or brown is the default color for all the motherboard. Basically, the motherboard is just a plug-in areas for all the central processing units, the memory, both the read-only memory and the read-only memory. So the next thing, once the information is processed, we have the monitor. The monitor is the output device, and so monitors are used to give out or relay back information, and information can be said to be processed data or information that has already been refined. So input devices always translate data from the human understanding. So the human input data according to how they understand. In most cases, or the most common input devices include the keyboard or the mouse. Examples of input devices include the keyboard, the mouse, the scanner. The pre-storage devices include the CDs. Also, we have the optical recognition, that's the barcode scanners. Those are input devices. We have the microphone, joystick for the gamers, and then we have the touch ball, touch screen, digital cameras, etc. That's some of the digital presentation of the input devices. You can see we have the trackball used in the on the keyboard. We have the joystick, we have the black pad, we have the tablet and the pen. So that's, so let's go straight to the CPU. So the CPU, we said, it is used to process information. So a specific chip is used to determine how other circuits in a computer is processed. So the CPU is the actual processing unit of any data. So depending with the speed, in case you want to increase the speed of a computer, you have to consider what your CPU can process. Remember, it doesn't process anything. It processes instruction. Previously, we had discussed about two components of a computer. We had the software, the hardware and the software. So the CPU processes the software bit of the computer. The CPU consists of three major elements. We have the control unit, we have the arithmetic logic unit, and some registers. We have the control unit. The control unit coordinates all the activities of the computer by determining the operation to perform, in what order to carry them. You can take note of it determines how to carry an instruction. We have the CU, that's the abbreviation for the control unit. The control unit transmits or coordinates the signals to other computer components. When you discuss about other computer components, it includes things like the input devices and the output devices. Can move on. We have the memory. The memory. First, we're going to focus on the memory. The memory enables a computer to store at least information temporarily or permanently. We have two major types of memory. We have the read-only memory, and we have the read-only memory and the read access memory. So the RAM, that's the abbreviation of the random access memory. It temporarily holds data and program for use during processing. Remember, we've talked about this memory is volatile. What do you mean by volatile? It can just be erased by, once the power goes off, or in case you close the application, the data goes. Any information stored in the random access memory is lost when the computer is turned off. RAM is the memory that the computer uses temporarily to store information as it is waiting to proceed to the central processing unit. So the bigger the RAM, the better it can hold information. So the RAM consists of the location or cells. Commonly, we call them the cells because they hold information. Each cell has a unique address which distinguish from each other. That makes it easier for the CPU to locate a specific place where to get the information. The read-only memory is part of a memory. It is programmed during the manufacturing time of a computer. Its content cannot be changed by users, and the information is stored permanently. So in the RAM, you're going to find some information like the basic input-output system. The abbreviation for that, they are called BIOS. Those are the booting instructions of a computer. So during the manufacture of the computer, the developers install the ROM or the read-only memory and give some software that control the computer. So let's go straight on to secondary storage. Secondary storage stores data and programs permanently, and it is retained after the power is turned off. Remember that once the power is turned off, your information is stored in either in a hard disk or in a floppy disk, a CD, and for some other cases, we have diskettes. The kinds of drives, we can have a pictorial look at this is an example of the drives. We have the DVDs, we have the diskettes, that's how diskettes, but these days, the diskettes are becoming obsolete. So we are moving away from diskette because the storage capacity of a diskette, it's approximately like 4 MBs. So that doesn't make any economic sense for any storage. We have another one that is a ROM or random read-only memory, which is the hard drive. The hard drive stores information magnetically. It's similar to the diskette, but it's more bigger and more economical. Remember, this can be removable or not removable. We can now go straight to the output devices. Output devices are pieces of equipment that translate the process information from the CPU into the form that a human can understand. Remember, the recipient of the information that a computer processes is the computer. Something to note, we have the human language and we have the computer language. Computers communicate using binary version, that's a 1 or zeros. So once the CPU presents the information to human readable information, the work of the output devices is to relay information. So an example can be the monitor, the printer, and you can see our model of a human being. The model of a human being, it's the green part. So examples of output devices include monitors, printers. We have different parts of printers. We have the dot matrix printers, the inkjet printers, the laser printers. And as we move on, you're going to see how different printers work. We have sound cards, etc., the controlling other devices, etc. So the next thing that we want to move on is a very important bit of computer software. So what is a computer software? A computer software, another name of a computer software can be said to be a program. So the word software and program mean one and the same thing. And this is an instruction. And this is an instruction that tells a computer what it is supposed to do. Right? Remember, computers use artificial intelligence. Artificial intelligence, we try getting information that is inhuman to a computer to make the computer work. So a computer relies 100% on softwares. We have two major types of software. We have the application software and the system software. We can start with the highlight about the application software. An application software help end users to perform general purpose task. When you talk about general purpose task, it include maybe typing, right, getting photos, right, and just to go to the mobile application world. Anytime you go to those guys or those students with Android phones, you go to Play Store, download a specific instruction. An example, WhatsApp. You download that application that can be classified as an application software because it does a specific task. A WhatsApp application cannot be used to as a chat application. Each of a chat application is Facebook. So an application software does a specific thing to the users. A system software, on the other hand, it enables the application software to interact with the computer. Previously, when we were talking about the hardware, we discussed about the input devices, we discussed about the output devices, the CPU, and we have the memory. All the four elements must have a system software. It coordinates all the functions of the computer, and an example of that include an operating system. An operating system. The most common one we have, the most common one is the Linux, Microsoft operating system. For those people who are using phone, we have Android or Mac OS. That's just the interface of the Windows XP. It was an operating system. So these are examples of the application software that we are going to be discussing as we understand the computer world. Because remember, this unit is computer application. How do we apply computers in our studies? So an example includes the word processors, spreadsheets, database managers, graphics, etc. We have different types of computers. We have the microcomputers, we have the mini computers, mainframe computers, supercomputers. All these computers work or uses the same anatomy, where we have the input, output, we have also the memory and storage. So the personal computers, which is the computers that we use, the microcomputers, we have the laptop, desktop, the workstation computers. All those are very, very common. The mini computers, you can see, we are going to transfer all these materials on our e-learning platform so that you can read about different computers and how they differ, because depending on the work you're going to be working on, each computer has its work. You can classify a computer based on the work it does, depending on the amount of money you have. So what are some of the characteristics of computers, or why do we use computers? The first characteristic is a computer stores large amount of data and information for a longer time of period. Remember, we are comparing these with the human mind. The other thing is the process. A computer processes data, information with high accuracy, speed, and lastly, we use another characteristic is that it enables the sharing of information via a network, right? So just these are easy illustration of how a computer processes. So from data to a computer to information and also lastly to knowledge. We're going to be discussing about that as we move on. So that's a representation of how data moves from information. And then something I want to mention that is very, very important that you're going to be working on, it's about computer viruses. Remember, a computer virus is an application software that is designed or written to destroy other programs. It has the ability to attach itself in another application and destroy itself. So we'll be discussing further on that. These are examples of computer viruses, and these are an animation of how a computer looks like when it's not well. So how do you deal with the viruses. We have antiviruses, and you can install it as an application software. So that's just a statement of that. With that, I think we're going to stop there for today, and we are going to proceed with the other section of the presentation via the online platform. So thank you.
These televised lectures supplement our robust online learning going on our MKU online platform. You can view more on our televised lectures via our online platform. We are in a digital era, and Mount Kenya University knows this. The following are the steps to follow so as to complete your online application. Download the application form from the website www.mku.ac.ke. Attach copies of your academic certificates and ID. Pay the application fees via M-Pesa pay bill number 270988. Your ID is the account number. 2,000 shillings is the charge for a postgraduate. You can also deposit in the bank accounts provided on the website. Then email all the above to apply@mku.ac.ke.